James Webb Space Telescope is the world's premier space science observatory. James Webb is solving mysteries in our solar system, looking beyond to distant worlds around other stars, and probing the mysterious structures and origins of our universe and our place in it. And now James Webb has captured an immense, rare explosion, which is a million times more brighter than our Milky Way galaxy, that shook all the theories. Also, tellurium, an element that is rarer on Earth than platinum, was recently discovered by astronomers, using an incredibly intense gamma ray as a guide in the aftermath of two dense star corpses, located roughly 1 billion light-years away. The element iodine, a reactive nonmetal that is necessary for most of life on Earth, is thought to have been within the kilonova explosion as well, with the two elements residing side by side on the periodic table. This finding advances our knowledge of the origin of the universe's heaviest elements. Join us today as we explore more about this new amazing discovery done by James Webb. Since the very first discovery of gamma ray bursts more than 50 years ago, science has advanced significantly. During that period, the U.S. had sent gamma ray detectors into space to track Soviet nuclear experiments. In 1967, these satellites saw a rapid flash of gamma radiation far above Earth. The signal was so bright from that of a nuclear weapon that researchers at Los Alamos National Laboratory stored it for further analysis. Numerous further ones were observed in the following years, but until powerful X-ray signals were connected to distant galaxies by ground and space-based observatories in the late 1990s, the enigma surrounding these events persisted. Gamma-ray bursts are now being discovered every week. Astronomers believe that the majority of them were brought on by huge stars exploding near the end of their lives. A subset of gamma-ray bursts known as kilonova are produced when neutron stars collide. These stars were once big enough to explode as supernova, but not massive enough to collapse black holes. In October 2022, the brightest long-duration gamma-ray burst ever observed was discovered. Known as BOAT, or the brightest of all time, its peak lasted several minutes and was so intense that it blinded most space-based gamma-ray observatories. But the recent kilonova in March of this year, known as GRB 230307A, offered strong hints about its neutron star origins, in addition to very clear evidence of heavy metals. This gamma-ray burst, which is a million times more bright than our entire galaxy, was caused by a collision of neutron stars that occurred 1 million light-years away. It lasted for about 200 seconds and was the second brightest gamma-ray burst ever observed. Furthermore, with the help of James Webb Space Telescope, astronomers were able to observe that the explosion served as a cosmic chemical factory, producing some of the rarest substances on Earth, which is tellurium. Tellurium is even more precious than platinum. It is used in many metal alloy applications, such as semiconductors, solar cells, and oil refining, and many more. Tellurium is rare on Earth, but it has been found in old stars and planetary nebulae. Since iodine has been shown to help reduce stress and inflammation in humans, it is necessary for life on Earth. This element was also discovered with the current findings. Although big stars are known to forge materials lighter than iron, even the most massive stellar bodies are unable to create cores that are hot and dense enough to forge heavier elements like tellurium, gold, or platinum. When stars can no longer perform nuclear fusion, they collapse due to gravity, producing neutron stars, which produce mass so dense that a teaspoon of it would weigh 10 million tons. This extremely dense matter is released into the nearby area of neutron stars during their collision. This material has a lot of free neutrons, which atoms can absorb to form unstable atoms that eventually decay into the heavier elements in the periodic table, atoms with a high proton and neutron content. In addition, as these components decay, an electromagnetic radiation explosion known as a kilonova, a brilliant burst, is released. Kilonovas are challenging to observe, as they are very rare in our universe. These rare merging encounters can give rise to short gamma-ray bursts, which have been defined as bursts lasting less than 2 seconds. On the other hand, long gamma-ray bursts are typically linked to the devastating death of a big star and may last for many minutes. This kilonova, named GRB 230307A, is around 1,000 times brighter than the average gamma-ray burst that Fermi detects. It was first discovered by Fermi in March and is the second brightest gamma-ray burst to be discovered in more than 50 years of observations. Even if it came from a separate source, its 200-second duration puts it clearly in the category of long-duration gamma-ray bursts. Researchers believe that the now merged neutron stars, which the James Webb Space Telescope observed, were previously common enormous stars that were gravitationally bound into their own galaxy. When one of the two neared the end of its life and burst into a supernova, this star blasted out of its galaxy and landed 120,000 light-years away. The other star did the same. According to experts, the neutron-star pair remained gravitationally bonded despite being violently ejected from their galaxy. Many 100 million years later, on March 7th of this year, we witnessed their merging into one body. The estimated source of GRB 230307A was found in the sky by scientists using a wide range of ground and space-based instruments. Through the use of optical, infrared, radio wave, gamma-ray, and X-ray light frequencies, the source was observed to have the characteristics of a kilonova explosion. The kilonova light became unobservable from Earth during the later stages of the explosion as it moved into the infrared, but it made a great target for James Webb's extremely sensitive infrared detectors. Apart from finding the characteristic tellurium emissions, James Webb also located a spiral galaxy approximately 120,000 light-years away from the kilonova. According to the team, the binary pair of neutron stars that caused the kilonova ejected from this galaxy and traveled the length of the Milky Way together before spiraling together and merging. Because kilonovas are very short-lived, they only survive a few days or weeks, and because they are easily hidden by gas or dust in the galaxies they live in. It takes strong, sensitive telescopes like the James Webb to see them. Fortunately, Webb is not alone in this quest. Other telescopes and instruments can enhance its findings and expand its powers. For instance, gravitational wave detectors like LIGO and Virgo can detect the rippling effects of neutron star mergers in space-time. By combining their data and insights, we can better understand our universe and our place in it. Other radio telescopes like SKA and ALMA can also probe the afterglow of gamma-ray bursts. There are many more planned missions that could join this effort in the future. Scientists believe that without James Webb Space Telescope, the most potent observatory humans have ever sent into space, it would have been impossible to discover this heavy material near the neutron star merger. Indeed, James Webb did an excellent job by capturing this rare explosion. The observatory builds upon 3 decades of discoveries by the Hubble Space Telescope, which launched in 1990 and has revolutionized our understanding of the cosmos. The atmosphere of Earth obstructs some light wavelengths, such as infrared slices that are invisible to human vision, and affects our perspective of far-off celestial objects. Space telescopes with infrared capabilities can view newborn stars through clouds of gas and dust, analyze the makeup of planets circling other stars, and even go back in time to observe galaxies that formed immediately after the Big Bang. Compared to Hubble, James Webb Space Telescope can view a far wider range of the infrared spectrum and gathers 6 times as much light. As the newest prime space observatory in the world, it expands and enhances Hubble's observations. In the upcoming years and decades, what new findings about gamma-ray bursts, kilonovas, and rare elements will astronomers make? Time will tell, which is why science exists. I hope you enjoyed this video. Don't forget to hit the like button and subscribe to our channel for more interesting space-related content. Thank you very much for watching, and I will see you in the next video.